Good morning, Miss E.
Good morning, class. I'm Miss Ian. Today, I will be showing you guys an example questions of finding integrations based on the concept integrations as a reverse process of differentiations. So this is the first example. So in this example, we need to find the derivatives of xe to the power of x minus e to the power of x. As you guys can see from the first term, we have a function in x times by another function in x. In this case, we will need to use product rule to find the derivatives of the first term, which is xe to the power of x. Whereas followed by the second term, we can just differentiate as usual using the formula. Since we need to use product rule to find the derivatives of the first term, what I will do is I will rearrange this form to a form that I can use product rule to find the derivatives to the whole thing. What I mean is, let me define y as xe to the power of x minus e to the power of x so that I can use dy by dx. So what am I going to do is I'm going to factorize e to the power of x. Then I will need to put x minus 1 in the bracket. So by rearrange this form, then I can let u be equal to e to the power of x, and I can let v be equals to x minus 1, and we can use product rule to find the derivatives to the whole thing instead of only on the first term. Of course, if you prefer to use product rule to find the derivatives of the first term, then followed by finding derivatives of the second term, of course, that way is definitely correct. Okay, so for this, I'm going to put u equals to e to the power of x, and then v equals to x minus 1. Then du by dx equals to, when you differentiate exponent, I think everybody should remember that when you differentiate exponent, it's always the same. So e to the power of x after differentiation is still e to the power of x. And then dv by dx, when we differentiate x, a term in x, we always copy the coefficients, which is 1. And when you differentiate -1, a constant, it gives us 0. And the formula for product rule, which is dy by dx, equals to u dv by dx plus v du by dx. And after that, we just put everything in. It's like doing, if you guys think that it's easier to use this form, you can actually do like this, like cross multiply. Okay, so I'm gonna put the, okay, dy by dx equals to, put all this thing in, we have u times dv by dx, then we have e power x times 1, e to the power of x, then plus v du dx. So we have x minus 1 times du dx, which is e power x. So e to the, then we will have v times e to the power of x. So after that, we can simplify this. We have to expand and simplify. We have this. This is how we expand. And we have e to the power of x plus x e to the power of x minus e to the power of x. As you can see from this, this and this are the same, so it's cancelled off. So in the end, the answer to these questions will be x e to the power of x. This is the derivatives. Okay, let me put down the answer. So the answer to this is x e to the power of x. So next, I'm going to show you example 1b. Okay, in this example, we need to find the integrations of 2xe to the power of x. And then another integration is xe to the power of x plus 2. If you compare these two forms, it looks very similar. So the form at the left side, we have xe to the power of x times 2. But for the integration at the right side, we have xe to the power of x plus 2. The left side times 2, the right side plus 2. So for these integrations where we have x times e to the power of x, these two integrations can actually be found by doing integration by parts. But if you haven't learned integration by parts, we can actually use the result that we obtain from part A to get the integrations of part B. So in order to use the result that is obtained from part A, so I will need to relate these expressions by using an integration sign. So as we know that for this expressions at the left side, when we do differentiations, we get xe to the power of x. So which means the reverse process of differentiations will be integration. So when we do integrations, we get the expression at the left side. So now I'm going to relate this to by using integration sign, and xe to the power of x will give us the expressions at the left side, which is xe power x minus e to the power of x plus c. Okay, this is the result we can use to find the integrations for part B. Okay, so for part B, if you compare this thing and the result that we have, now we need to compare the things we need to find and the result that we have. The only difference is there's a 2 here, but for the result that we have, the 2 is not there. So the additional thing is the 2 here. So what we can do is we can insert 2 into the result that we have. What I mean is we multiply this whole thing by 2. So let me write down the result that we have from part A, which is e to the power of . Okay guys, you can see that I just write down the result that I get from part A. That's the same thing. I'm actually copying the same thing. Okay, and then as you guys know that actually for these two, the coefficients of x, e power x, whenever you do integrations, actually this number will just copy. So it doesn't really matter where do you put this number. What I mean is you can actually put 2 before the integration sign. Right? It makes no difference. It makes no difference because whenever there's a coefficient, we just copy. The constant number, we just copy. So it makes no difference even if you put 2 before the integration sign. So this is the thing we need to find. So you compare again. Compare this thing with this thing. Can you guys see what the difference now? You have to multiply by 2. So next thing, I will multiply this whole thing by 2. Then I will have 2 times of integrations x e power x. So if you multiply 2 to the left side, of course the right side you have to do the same thing. So each of this term also multiply by 2. So x e to the power of x times 2 will be 2x e to the power of x. And e to the power of x times 2 we have 2e power x. And constant times by 2 is still constant. So in the end, this thing can be expressed as, sorry guys, I forgot to write down the 2. So it should be 2x e to the power of x dx. So this is the result for the integrations to the left side. How about the integration at the right side? Okay, let's compare with the result that we get from part A. So if you compare this thing that you need to find with the result that you have, the things that is missing is plus 2. You might be thinking to do the same thing like the integration at the left side. You just insert plus 2. What I mean is, okay, let me write down the result that we obtain from part A. Okay, guys, as you can see from this thing is exactly the same as this result. I didn't do any, I didn't insert anything. So next, compare this with the things you need to find. These two, the only thing is missing is plus 2. Okay, so let's say you insert plus 2. You insert plus 2 to the left side, and then you insert plus 2 to the right side. So guys, please take note, if you are doing this, this is not right. This is not right. I put a cross here to show that this is wrong. Okay, what do you understand about these integrations when there's additions? So when there's additions, normally when you do integrations, you will need to integrate term, then followed by another term. What I mean is you need to integrate x e to the power of x, then followed by integrations of 2 dx. This is how you do integrations when there's addition or subtractions. So now if you compare again, this is actually the things you need to find, and you compare with the things that you have. The things that is missing is not just 2. The things that is missing is actually this whole thing is the thing that is missing that you have to insert instead of just inserting 2. So the correct way of doing this integrations. Okay, let me write down the result again that we obtained from part A. So we have this. This is the result we obtained from part A. This is the same as this. It's just copied from part A. Okay, what am I going to insert now is this whole thing. And I mean is if you compare, let us compare again. This is the thing you have, and this is the thing you want to find. And you can see that the things that is missing is this thing. This is the thing you need to insert. So I will insert this integration of 2 dx. So I insert this to the left side, then I have to insert the same thing to the right side. So in the end, this whole thing will become integrations of x e to the power of x plus 2 dx equals to x e to the power of x minus e to the power of x. And let me find the integration of this first. So integrations of 2 will be 2x. Integration of 2 with respect to x is 2x, but differentiate 2x is 2. Don't forget to put plus c. So this is the result. This is the answer to these integrations. So guys, please take note that when you have times 2 or maybe divide a number like times a fractions, you can just use this result that you obtain from part A to multiply or divide for whatever number that is missing for times and divide. But when there is additions or subtractions, a term, so you cannot just insert like what I showed in this line. That's not correct. You have to insert integrations of that term when you have addition and subtractions. Okay, so that's all for today. I hope you guys find this very useful. I will be sharing with you guys other solutions to many other tricky questions in the future. So thanks for watching. See you next time.